Compound angle. The angle formula for sine and cosine of the sum and difference of two angles A and B are sine A plus B is given as sine A cos B plus cos A sine B. Sine A minus B equals to sine A cos B minus cos A sine B. For cos A plus B, we have cos A cos B minus sine A sine B. Cos A minus B equals to cos A cos B plus sine A sine B. Note that sine A plus B is not the same thing as sine A plus sine B, and so on. Similarly, tan A plus B is given as tan A plus tan B divided by 1 minus tan A tan B. Tan A plus B once again is given as tan A plus tan B divided by 1 minus tan A tan B. Tan A minus B equals to tan A minus tan B divided by 1 plus tan A tan B. Let's take an example. Example 1. Given sine 45 degree equals to cos 45, which is 1 over 2. Sine 30 degree is half. Cos 30 degree is 3 over 2. Calculate sine 15 degree. Now, the solution. Sine 15 degree equals to sine 45 degree minus 30 degree, which is sine 45. If we use sine A minus B, that gives sine 45 cos 30 degree minus cos 45 degree sine 30 degree. Sine 45 is 1 over root 2. Cos 30 is root 3 over 2 minus cos 45 1 over root 2 multiplied by sine 30, which is half. Then on simplifying, we have root 3 minus 1 over 2 root 2. Example 2. Prove that cos y minus pi plus sine y plus pi over 2 equals to 0. Solution. Cos y minus pi equals to cos y cos pi plus sine y sine pi. And of course, cos pi is minus 1. That gives cos y into minus 1. And sine pi is 0, which is cos y minus 1 plus sine y multiplied by 0. That gives minus cos y. On simplifying sine y plus pi over 2, we have sine y cos pi over 2 plus cos y sine pi over 2. And cos pi over 2 is 0, y sine pi over 2 is 1. And that simplifies to cos y. Hence, cos y minus pi plus sine y plus pi over 2 equals to minus cos y plus cos y, and that gives 0. Example 3. Show that tan 45 plus A, tan 45 degree plus A equals to 1 plus tan A over 1 minus tan A. Now the solution. Tan 45 degree plus A is given as tan 45 plus tan A divided by 1 minus tan 45 tan A. And that gives tan 45 to be 1. And we have 1 plus tan A divided by 1 minus tan A. Let's look at the next page. Example 4. Show that sine x plus y into sine x minus y equals to sine square x minus sine square y. Now, the solution. The left hand side is sine x cos y plus cos x sine y. Multiplied by sine x minus y gives sine x cos y minus cos x sine y. Now this can be taken as a plus b into a minus b, where our a is sine x cos y and our b is cos x sine y. Once again, we have a to give us sine x cos y and b to give us cos x sine y. That gives in the bracket a plus b into a minus b, which is a square minus b square. Our a square is sine x square cos x sine square x cos square y. That's our a square. And our b square is cos square x sine square y. And on simplifying, cos square y is 1 minus sine square y. And sine square y is 1 cos square x is 1 minus sine square x. So that the next line gives sine square x into 1 minus sine square y minus into 1 minus sine square x into sine square y. On simplifying, we have sine square x minus sine square y, which is the right hand side. And that's what we asked to show. Example 5. Example 5. If tan x plus y is 4 over 3 and tan x is 1 over 2, find tan y. 2. Evaluate without using table. Cos 75 degree, sin 75 degree. Now the solution. Tan x plus y is tan x plus tan y divided by 1 minus tan x tan y. And we are given that tan x plus y is 4 over 3. That equals to 4 over 3. Tan x is half. So substituting, half plus tan y divided by 1 minus half tan y. And that gives 1 over 3. 4 over 3 equals to 4 over 3. And cross multiplying, we have 3 into half plus tan y equals to 4 into 1 minus half tan y. And on simplifying, we have 5 tan y equals to 4 minus 3 over 2, and that gives 5 over 2. So tan y is equals to half. Tan y equals to half. That's what we are asked to find. Now the next page, on page 25, cos 75 degree. Cos 75 degree equals to cos 45 degree plus 30 degree, and that gives cos 45 sin cos 45 cos 30 minus sin 45 sin 30 degree. Cos 75 degree once again equals to cos 45 degree plus 30 degree, and that gives cos 45 cos 30 minus sin 45 sin 30 degree. So cos 45 is 1 over root 2, while cos 30 degrees is root 3 over 2. Sin 45 is 1 over root 2 and sin 30 is 1 over 2. On simplifying, we have cos 75 to give root 3 minus 1 divided by 2 root 2. Similarly, sin 75 degree is sin 45 degree plus 30 degree, and that gives sin 45 cos 30 degree plus cos 45 sin 30 degree. On simplifying, sin 45 is 1 over root 2, cos 30 is root 3 over 2, plus cos 45 1 over root 2, sin 30 is half, and that gives root 3 plus 1 divided by 2 root 2, because the SM is 2 root 2. Now yeah, example 6. Reduce the following to the sine of one angle. Reduce the following to the sine of one angle. A, sin 37 degree cos 21 plus cos 37 sin 21. B, sin 70 cos 3t minus cos 70 sin 3t. The solution. Now, if you look at the first one, sin 37 cos 21 plus cos 37 sin 21 could be written as sin A plus B, where our A is 37, our B is 21. And that gives sin 37 plus 21, and that reduces to sin 58 degree. The B part, sin 7t cos 3t minus cos 70 sin 3t could be written as sin A minus B, where our A is 70 and our B is 3t, and that gives sin 70 minus 3t, which is sin 40. Now let's look at the next page, page 26. He has to solve the equation as an assignment. 4 sin x minus 20 degree equals to 5 cos x for values of x between 0 and 90 degree. 2. Reduce the following to the cosine of one angle. Cos 71 degree cos 33 degree minus sin 71 degree sin 30 degree. B, cos pi over 3 cos pi over 4 plus sin pi over 3 sin pi over 4. And of course, you have 3. Given cos A equals 0.42, sin B is 0.73, evaluate sin A minus B, cos A minus B, tan A plus B, correct to 4 decimal places. 4. Show that tan A plus tan B is sin A plus B divided by cos A cos B. 5. Simplify tan 30 degree plus tan 40 degree divided by 1 minus 30 degree tan 40 degree. 1 minus 30 degree plus 40 degree. Simplify tan 30 degree plus tan 40 degree divided by 1 minus 30 degree tan 40 degree. And that one, there is a division line there. There is a division line. Tan 30 degree plus tan 40 degree divided by that, there is a line, the division line is there, divided by tan, it should be divided by tan simplify tan 30 degree. I'm taking that 5 again, simplify tan 30 degree plus tan 40 degree divided by 1 minus tan 30 degree tan 40 degree. 6. Show that tan cos 90 degree plus a equals to minus sin a, and 2. Sin 90 degree plus a is cos a. Now let's look at the next page. Multiple and submultiple angles formulae. Multiple and submultiple angle formulae. Sin 2a. Sin 2a is given as sin a plus a, which is sin a cos a plus cos a sin a. Sin 2a could also be written as 2 sin a cos a. Cos 2a is cos a plus a, which is cos a minus sin a, and that gives cos square a minus sin square a. But we know that cos square a is 1 minus sin square a, and sin square a equals to 1 minus cos square a. So cos 2a can also be written as 2 cos square a minus 1, or 1 minus 2 sin square a. In the first case, we are replacing sin square a with 1 minus cos square a. So if you simplify, you have 2 cos square a minus 1. And the second one, we have cos 2a equals to cos square a minus sin square a, replacing cos square a with 1 minus sin square a, and simplifying, you have cos 2a equals to 1 minus 2 sin square a. And of course, tan 2a is given as tan a plus tan a divided by 1 minus tan a, which is 2 tan a divided by 1 minus tan square a. Sin 3a, sin 2a plus a is 2 sin. I'm here, sin 2a, because sin 3a is sin 2a plus a plus sin 2a cos a plus cos 2a sin a. Or we could also write it as 2 sin a cos square a. 2 sin a cos square a. Why this? I simplify sin 2a to give us 2 sin a cos a. And of course, cos a will multiply this cos a will give us cos square a. I already have 2 sin a outside. Is that taken? Let me go over it again. Sin 2a from this place. Sin 2a is 2 sin a cos a. So 2 sin a cos a will multiply this cos a. And that will give us 2 sin a cos square a. Then cos 2a is written as cos square a minus sin square a. Already you have sin a here. When you simplify this one, you have cos square a sin a, which is this next line, multiply by sin a, multiply this one will give us sin cube a. And when you simplify, you have 2 sin a cos square a plus sin a cos square a will give us 3 sin a cos square a minus sin cube a. Now let's look at the next page. Now the next page you have, since cos square a is 1 minus sin square a, 3 sin cos square a. I've replaced cos square a with 1 minus sin square a minus sin cube a sin 3a. Cos 3a gives 3 sin a minus 3 sin square a minus 3 sin cube a minus sin cube a, and that gives 4 sin cube a. So cos 3a is 3 sin a minus 4 sin cube a. This is what I'm saying. If you look at this page 28, 3 sin a will replace cos square a with 1 minus sin square a, and already we have sin cube a here. So if you expand this one, the next line should be 3 sin a minus 3 sin cube a square, and this is 1. So that gives 3 sin a minus 3 sin cube a. Already have another sin cube a here. 3 sin cube a minus sin cube a will give us 4 sin cube a. So cos 3a is 3 sin a minus 4 sin cube a. Now, similarly, cos 3a is 4 cos cube a minus 3 cos a. So tan 3a is given as tan 2a plus a, which is tan 2a plus tan a divided by 1 minus tan 2a tan a. And of course, this tan 2a can be written as 2 tan a divided by 1 minus tan square a, plus tan a is already there in the numerator, divided by 1 minus tan 2a. tan A. I can take tan A first, then tan A, then tan 2A is written as 2 tan A divided by 1 minus tan square A. Now simplify numerator and denominator. So if I cross multiply the numerator, I will have 2 tan A plus tan A minus tan cube A divided by 1 minus tan square A. And numerator will give us 1 minus tan A. This tan 1 minus tan square A will multiply this one, and you have 1 minus tan square A minus tan A times 2 tan A will get 2 times square A divided by 1 minus tan square A. 1 minus tan square A will cancel 1 minus tan square A, and you have this one. Then the next line, you have 2 tan A plus tan A will give us 3 tan A minus tan cube A. And the denominator, you have 1 minus tan square A minus 2 tan square A will give us 3 tan square A. And let's move to half angle formula. The half angle formula, or half angle formula, if we replace A by A over 2 in the double angle formula, we have, in the double angle formula for sine 2A is 2 sine A cos A. So replacing for 2A, we will replace A with A over 2. So we have sine 2A is the same thing as sine A, because that will cancel these two. So we have sine A. Then we will know that sine 2A is 2 sine A cos A. Then replacing A by A over 2, so 2 sine A, which is the same thing as sine A, if I replace A by A over 2, equals to 2 sine A over 2 cos A over 2. And for cos A, which is cos A is giving us cos square A over 2. Cos A is cos square A over 2 minus sine square A over 2. Why this? Because cos 2A is cos square A minus sine square A. Now replacing A with A over 2, you have cos A equals to cos square A over 2 minus sine square A over 2. And that reduces to 2 cos square A over 2 minus 1. If you replace if you replace A with A over 2 in the formula, cos 2A, which is 2 cos square A minus 1. So we have cos 2A is 2 cos square A over 2 minus 1. And similarly, if you replace A with A over 2 in the formula, cos 2A equals to 1 minus 2 sine square A. So we have cos A equals to 1 minus 2 sine square A over 2. And similarly for tan A, tan 2A is 2 tan A over 1 minus tan square A. So replacing A with A over 2, you have tan A equals to 2 tan A over 2 divided by 1 minus tan square A over 2. Now this result enable us to express tan A cos A and tan A in terms of tan A over 2. For instance, if tan A over 2 is t, we have tan A to give us 2t over 1 minus t squared. Tan A to give us 2t over 1 minus t squared. Why this? If you look at tan A, if you look at the formula, if you look at the formula, tan A, which is 2 tan A, this formula, tan A is 2 tan A over 2, 1 minus tan square A over 2. So I replace tan A over 2 with t. So I have tan A to give us 2t over 1 minus t squared. That's this one here. So sine A is same thing as this. 2 sine A over 2 cos A over 2. So dividing through by cos square A over 2 plus sine square A over 2, which is 1. And dividing numerator and denominator by cos square A over 2. On the next page, we have sine A to give 2 sine A over 2 cos A over 2, 1 plus sine square A over 2 cos square A over 2, and sine A over 2 by cos A over 2 is tan. So 2 tan A over 2 divided by 1 plus tan square A over 2. And of course, we say tan A over 2 is t. So we have 2t over 1 plus t squared. Similarly for cos A, we have 1 minus t squared over 1 plus t squared. Example 1. Show that sine 2a over 1 minus cos 2a is cot A. Show that sine 2a over 1 minus cos 2a is cot A. Now, solution. Sine 2a is 2 sine A cos A. And cos 2a is cos square A minus sine square A. Substituting sine 2a, 2 sine A cos A divided by 1 minus cos 2a. Cos 2a is cos square A minus sine square A. And simplifying that, we have the denominator to give 1 minus cos square A plus sin square A. And that gives 2 sin A cos A divided by 2 sin square A. Why 2 sin square A? I replace cos square A with 1 minus sin square A. If you replace that with 1 minus sin square A, then you have the denominator to give us 2 sin square A. And of course, sine will cancel sine, and you are left with cos A over sine A. And that gives cot A. That's what it has to show. Then the next page